principal ma'am, headmistress ma'am, all the supervisory heads and the teachers, and welcoming all the lovely people who are watching it live.
Maths plays a key role in everyone's life. To accomplish our day-to-day tasks, we apply mathematics directly or indirectly. Math Without mathematics, there is nothing you can do. Everything around you is mathematics. Maths around you is not just numbers, but it is the way one perceives it. A very hearty welcome to all present here. The day brings a lot of excitement as it heralds a day where students of Kulachi Hansraj Model School will exhibit their love towards mathematics. Today is the first day of celebrating the exciting week of appreciating mathematics beyond the textbooks. Students of classes 7 and 8 will showcase their talent and creativity and will present the legacy of famous Indian mathematician Srinivasa Ramanujan and recreation with numbers.
Mathematics makes our life orderly and prevents chaos. Certain qualities that are nurtured by mathematics are power of reasoning, creativity, abstract or spatial thinking, critical thinking, problem solving ability, and even effective communication skills.
Let us all commence this program by repeating the
Now, I would like Vanshika to proceed with the program.
We are delighted to have a special guest of honor, Miss Leena Malik, from an online school, High Math Enthusiast in Ohio, USA. She will be sharing with us her vision about mathematics beyond textbooks.
Hello, Kalachi Hansraj. What if you could see math? What do you imagine math equations would look like if you could just visualize them? Circles? Squares? Or maybe more interesting 3D shapes like icosahedron? Hello, everyone. My name is Leena Malik, and I'm a math enthusiast. I teach 11th and 12th graders to think and visualize math at Odala. It's an online school in Ohio, USA. What is textbook math? Some of you might find math as a dry process where you just follow the steps and get the answer. That is not really what math is. Of course, you need the process, but once you master these processes, math can open an interesting world for you. Today, I'm here to talk about one such interesting application in the rising field of cryptography. So let's get started. I'm going to share my screen. So if you see me looking somewhere else, that's where I'm looking. So let's start with talking about the maths that you learn in your textbooks first. Polynomials. Whole number powers of x create polynomials of various degrees, like lines, degree 1 polynomials, parabolas, or quadratics. They are degree 2 polynomials. Cubics are degree 3 polynomials, and so on. Polynomial graphs are also very interesting with lots of terms depending on their degrees. You only need 2 points to find the line through it. If you have 3 points, you can find the exact equation of the quadratic. 4 points can determine a cubic equation. We can go on. Now about cryptography. A very simple introduction to cryptography can be creating secret codes. Have you ever wanted to share a secret with your best friend without anyone knowing it? You might have created a code that looks like this. You can assign a number to each letter and create a secret code. Your friend has to know the code you used to decode this message. For example, hello would be 0805121215. What if someone hacks into this code? It's not safe. Cryptography is the study of a variety of codes like the simple one we just created. Cryptography and codes are used to keep information safe and to stop people from stealing them. For example, a bank needs to secure their vault's passcode. They could use a simple method with one key. But what if the holder of the key is unavailable or gets robbed? What if the key is compromised by a malicious hacker or the holder of the key turns rogue and uses their power over the vault to their benefit? Shamir's secret sharing. Adi Shamir. He was an Israeli cryptographer who developed a method of sharing secrets. It's known as Shamir's secret sharing, where different fragments of the key are given to different people. In this way, multiple people need to work together to combine a whole key and decode the entire message. Here is how it works. Let's say our secret code to the vault is 1729. We want to share this code between 4 very trusted people, Mr. A, Mr. B, Mr. C, and Mr. D. We want at any point, no less than 3 people should be able to open the vault. How should we share the code? So first, we generate 2 random numbers. Let's say -101 and 83 are my 2 random numbers I generated. We're going to use these 2 random numbers and our secret code to create a quadratic equation, just like the one shown here. So -101x squared plus 83x plus 1729 is my quadratic equation I created with these 2 random numbers and my secret code. Now, let me show you what the graph of this equation would look like. So here is the graph of my equation I created. -101x squared plus 83x plus 1729. As you can see, the point 1729 is the y-intercept of my parabola. This is my secret code. Now, we're going to give the key to this secret code. We're going to give 4 random points. We're selecting 4 random points on this parabola, and we're going to just give 1 to each of these trusted people. So let's say my first point, 1,1711, that's my key that I give to Mr. A. My second random point on this parabola, -2,1159, I give to Mr. B. That's the key Mr. B holds. Third point on this parabola, just randomly pick third point, 3,1069, I give to Mr. C. That's his key. And the fourth point, -4 comma -219, I give to Mr. D. Does all the four people know, any of them know the secret code? I don't think so. All they have is the key that was given to them. It's not, none of them know the secret code. So what if Mr. D decides to rob the bank? All he has is his key. He does not know what the quadratic equation looks like. He does not know what the secret code is. We're gonna just still leave the secret code here so you can see where our secret code is. Now, remember, Mr. D has just one key. Can he figure out the secret code from his one key? Remember, to figure out the secret code, he needs to find what is the equation of our parabola. He has to find where the parabola is. With his one key, he can only figure out infinite amount of parabola that will go through that point. There are infinite amount of parabolas that can go through the point that Mr. D has. So there is no way he can crack the code. Now, let's assume Mr. D was able to include Mr. C in his plan. Can Mr. C and Mr. D together figure out the code? But if they work together with both their keys? Remember, they have to find the parabola that contains the secret code. Can they figure out that parabola? Look at that. With the two keys that they hold, again, there's going to be infinite amount of parabolas that they can create. So there is no way they're going to figure out which one is the parabola that contains the secret code. So two of them working together cannot figure that out either. Remember we said you need 3 points at least to find the exact equation of your quadratic? So we need at least 3 people to combine their key so they can figure out what the secret code is. Let's say Mr. A, Mr. C, and Mr. D are now working together. They have 3 points on that parabola, the keys that they have. They are able to figure out the exact equation of the parabola that will go through that 3 points. And remember, the y-intercept of that equation would give them their secret code. If Mr. A does not want to be part of that plan, we could have Mr. B, Mr. C, Mr. D could do it. We could have Mr. A, Mr. B, Mr. C could do it. Or Mr. A, Mr. B, and Mr. D could do it. Remember, you only need 3 people to crack that secret code. Interesting, isn't it? How using that simple math, we can design an unbreakable safe. By the way, higher degree polynomials can give it even more security. So if instead of using a quadratic, you would have used a degree 3, degree 4, or degree 5 polynomials, you could share that key with more number of people, and it would take more number of people to crack the code. So you could make your safe even safer. Now, in the end, I want to leave you with this fun fact about our great Indian mathematician Ramanujan. Did you know our secret code 1729? It's a very famous number. It is called Hardy-Ramanujan number. It is the smallest number that can be written as the sum of cubes in 2 different ways. Thank you so much, everyone, for having me here today. And I hope I was able to spark, if not a lot, at least a little interest in your minds to seek math in your life. Thank you, everyone, and have a great day.
Thank you so much, ma'am. You have shared an intriguing way of mathematics. We really learned something new and interesting from you. And this information will continue for the long pace of it.
Hearty gratitude to Ma'am Principal for her farsightedness that we are accomplished to show our talent across this digital platform. I would like to request Principal Ma'am to enlighten our spirits with her words of wisdom.
Very pleasant morning to everyone present here and to all those who are watching this program on YouTube. Hope you all are fit and fine at home and taking good care of yourself. I am really grateful to Mrs. Leena Malik, high school mathematics teacher from Ohio, USA, for joining our Maths Week celebration through her inspiring video message for all of us. She has indeed taken an interesting example of using mathematics in cryptography. Thank you for joining us today, Mrs. Leena Malik. It is appreciable. Children are learning coding these days, which involves deeper knowledge and understanding of mathematics. Mathematics is a powerful tool for global understanding and communication that organizes our lives. Mathematics helps us understand the world and provides an effective way of building mental discipline. It encourages logical reasoning, critical thinking, creative thinking, abstract thinking, problem solving ability, and even effective communication skills. We at Kulachi Hansraj Model School always strive hard to provide our students with blended teaching learning pedagogies to enhance a variety of skills for their holistic development. Specifically in mathematics, we use creative teaching ways to achieve learning outcomes set by NCERT and CBSE, enhancing 21st century skills, giving an array of myriad activities and opportunities to children to nurture the young minds is a need of the hour. Variety of programs are organized from time to time. Expert talks by international partner school teachers, collaborating with other schools in order to provide ample exposure and motivation to our students are few of the many endeavors. We want our students to appreciate mathematics in their day-to-day life rather than study it only as a subject. Every year, to commemorate the birth anniversary of the famous mathematician Srinivasa Ramanujan, we organize various activities for our students like mathitude test, intra-class mathematics, a competition, and art activities, and many more. Ramanujan's life has inspired generations of mathematics enthusiasts by showing his love for the subject and doing and going deeper to understand it further. We have by far celebrated every subject week, continuing the series. As you already know, children, that we have already celebrated English week, Hindi week, SST week, science week. Now this week we are going to celebrate mathematics week. So continuing the series, we are celebrating mathematics weeks from 22nd December to 29th December. Kulachians from PS school 3 plus children to class 12 will showcase their knowledge, talent, and creativity based on the special theme mathematics beyond textbooks. Today, this is day one of the Mathematics Week celebration. Students of classes 7 and 8 would be presenting Legacy of Ramanujan with recreation of numbers. I'm waiting to see their exploration. I know you all are excited to show your work. On day 2 23rd December, students of classes 5 and 6 will carry forward the euphoria of number with numero ecstasy. I'm curious to see the use of numbers beyond textbook by young ones. On day 3, 24th December, students of classes 11 and 12 will take you on a magical journey to mathematics, the gateway and key to existence. Looking forward to the senior students' presentation about mathematics beyond textbooks. On day 4, 26th December, students of classes 3 and 4 will usher everyone to the royal kingdom of maths. I am keen to know the perspective of young children towards the learning journey of mathematics. On day 5, 28th December, students of classes 9 and 10 will present the unsung life story of a mathematical genius whose works are extraordinarily amazing with Shunya Se Anand. The limit does not exist. Waiting to witness secondary level students thinking about the subject. On day 6, 29th December, students of class primary preschool and to class 2 will exhibit the existence of reasonable and logical solutions to all problems in life with friends with mathematics. Yes, one has to become friends with a subject to further learn and explore. I am eagerly waiting for the presentation by the little ones. I can proudly say that it has been a wonderful experience to see our children's imagination and creativity getting unleashed on this virtual platform. Our students are setting a benchmark in this new era of online education. To all my students, I would say your fervent participation is integral in making the virtual program a success. I would also like to extend my heartfelt gratitude to the parents who have been immensely supportive in all the endeavors. The efforts of the teachers is also appreciable. Each one of you is tuning yourself with the use of technology during the lockdown period. I appreciate it. I hope you are enjoying the process of evolving as a teacher. This message is for all the teachers. I'm truly looking forward to the creative presentation of the students that they would exhibit today as well as through the week. My best wishes to all the participants. Let us appreciate the efforts of the students and create indelible memories to be cherished for a lifetime. Thank you very much. All the best to class 7 and 8. Thank you very much.
Thank you so much, ma'am.
Thank you, ma'am, for encouraging us with your specious words. We promise to live up to your expectations and do our best. Today, the budding mathematicians of Kulachi and Sraj Model School will start this program to commemorate the 133rd birth anniversary of famous Indian mathematician Srinivasa Ramanujan.
According to this short snippet on Ramanujan's life, depicted by the students of class 8J, his mentor, Professor G.H. Hardy, a celebrated mathematician himself, who considered his own life's greatest contribution to mathematics as the discovery of Ramanujan. Professor Hardy proclaimed that numbers were the personal friends of Ramanujan. If Ramanujan didn't know what a proof was, evidently there was no way he knew his theorems were correct. Then how did he know about the theorems in the first place? Hardy suggested Ramanujan's theorems were a result of a curious mix of induction and intuition. So let us see the episode 1 of the play in which we will learn about the man who knew infinity.
Ramanujan, tell me why. I'm your mother. Won't you tell me?
Why don't you understand? I don't like going to school. I keep on failing the test which the teachers give me and exams which give my classmates a reason to tease me.
But to sit at home and avoid school is not a solution, is it?
But Ma,
Hey, what's happening here?
Seems like this boy also is going to school like us. Don't you think so?
If I'm allowed to interrupt, I guess this boy was Ramanujan. Do you know he mastered trigonometry by the age of 13 and solved infinite series by the age of 14 and also started inventing new ways to solve higher order equations by the age of 15 without even any formal education in mathematics.
Oh, I knew him. I was just joking. But yes, Srinivasa Ramanujan was an Indian mathematician who made great and original contributions to many mathematical fields, including complex analysis, number theory, infinite series, and continued fractions. He was discovered by G.H. Hardy and J.E. Littlewood.
Wow! But how did I not know him? Ramanujan, a dispassionate young boy, yet not interested in studying, asked his friend for a library copy of the book, The Synopsis of Elementary Results in Pure and Applied Mathematics. Yes, what you wanted?
thank you. This book of mathematical tables, algebra, theory of equations, plane and spherical trigonometry.
The book that was a major source of information for the legendary and self-taught mathematician Srinivas Ramanujan. The book is also acknowledged as the key element in awakening the genius of Ramanujan. Ramanujan's interest in mathematics started increasing tremendously day by day. He started solving questions on paper.
Cos A plus B is equals to cos A cos B minus sin A sin B.
He kept on scribbling on the same piece of paper again and again because he could not even afford to buy paper.
In 1909, he was married to 10-year-old Janaki. Ramanujan rose in prominence among Indian mathematicians, but his colleagues felt that he needed to go to West to come in contact with forefront of mathematical research.
In 1913, he began writing letters to British mathematicians. Ramanujan started writing letters to the professors at the University of Cambridge. His first two letters went unanswered, but his third, of January 16, 1913, to G.H. Hardy hit its target.
This is impressive.
Yes, Hardy, you are right. This boy is incredible.
I think we should call him to England.
Yes, I think we should.
Out of these, G.H. Hardy was to be the one who would believe in Ramanujan's skills. Hardy and his colleague J.E. Littlewood was impressed enough to call Ramanujan to England. On the other hand, Ramanujan also decided to go to England to meet G.H. Hardy, but his wife insisted on going with him. Can I come along with you?
No, you must stay here and take care of the family. You're too young right now.
You won't forget me, will you?
I won't.
Ramanujan landed in England.
Good morning, sir.
So you are S. Ramanujan.
Yes, sir.
We were amazed by your discoveries. So if you would like to tell us, how do you come up with all this?
Well, it just happens to come to me. Nothing else.
Impressive. I think you should start listening lessons in our university. You will surely learn a lot.
But I am here to publish. The letter only contained a sample of my discoveries.
Oh, you have more to show.
Yeah, of course.
But this would take a lifetime.
Or maybe two.
Ramanujan started taking lectures, but the others did not believe in him. When no one agreed to Ramanujan, they decided to throw the young boy out. But Hardy knew how precious Ramanujan was. Later on, making everyone realize the importance of Ramanujan to the mathematical field. Ramanujan was welcomed by everyone.
Well, the duo made stupefying discoveries together. They reached great heights and found the theorems and inventions that have changed our world and science today.
In a famous anecdote, Hardy took a cab to reach to Ramanujan. When he got there,
My cab number 1729 was rather a dull one.
No, Hardy. It is a very interesting number. It is the smallest number expressible as a sum of two cubes in two different ways. That is, 1729 is equal to 1 cube plus 12 cube, which is also equal to 9 cube plus 10 cube.
Excellent job, Ramanujan.
Thank you, sir.
This number is called the Hardy-Ramanujan number, the smallest number which can be expressed as sum of two cubes in n different ways. This number have been dubbed as taxi cab numbers. The next number in the sequence is the smallest number that can be expressed as sum of two cubes in three different ways. One of those numbers is 87,539,319.
For those of you who are unfamiliar with this infinite series, which has come to be known as the Ramanujan summation, states that if you add all the natural numbers, that is 1, 2, 3, 4, and so on, all the way to infinity, you will find that it is equals to minus 1 upon 12.
He returned to India in 1919. An onset of various kinds of illness had made him weak. He was then diagnosed with vitamin deficiency and tuberculosis.
in 1920, he died aged 32 in Kumbakonam, but not before leaving this world with a plethora of theorems and discoveries in mathematics, which were researched and proved to be true years after his death. In an interview with Ramanujan's wife, Janki Amal, she stated,
All I can tell you is that day and night he worked on sums. He didn't do anything else. He wasn't interested in anything else, just sums. He wouldn't stop work even to eat. We had to make rice balls for him and place them in the form of his hands. For him, in this universe, maths was everything. On his deathbed, he told me that his name would live for 100 years.
after the death of Ramanujan, he was awarded the Nobel Prize in 1983. Also, an award is named after him called the Ramanujan Award, and college was inaugurated in his honor in the year 2010. Also, our former Prime Minister Manmohan Singh in the year 2012 declared his birthday, December 22nd, as the National Mathematics Day.
1914, Paul Erdős, a Hungarian mathematician, in an interview with Hardy.
So, Hardy, what did you see in Ramanujan?
I almost immediately recognized Ramanujan's extraordinary, albeit untutored brilliance, and I and Ramanujan became close collaborators.
So, what is his greatest contribution to mathematics?
It was the discovery of Ramanujan. My association with him is the one romantic incident in my life.
Ramanujan had produced groundbreaking new theorems, including some that defeated them completely. They had never seen anything like it before, and some recently proven but highly advanced results. So, what did Littlewood and Hardy have to conclude about Ramanujan? I can believe that he is at least a Jacobi. Although some of his results were incorrect, others showed amazing insight, and that they must be correct, since no one would have the imagination to make them up. Ramanujan was clearly a genius of the first order.
I can compare him only with Euler or Jacobi. In a short life of just 32 years, he changed the course of mathematics, but the man has his own shares of struggles.
Wow, this performance was really miraculous. There is a lot to learn from Srinivasa Ramanujan's experiences. Shaurya, do you know we have number crunchers?
Number crunchers? Who are number crunchers?
They did the calculation of fundamental operations very fastly.
Can we see them?
Yes, sure. So here we meet our number crunchers.
Calculation skill plays an important role, which has to be acquired by everyone. Continuing in the series of Mathematics Beyond the Textbook, let us all witness number crunchers of Kullachi Hansraj Model School. Here we have our fastest calculator Arnav Jain and Boardma's founder Vanchika Gupta.
Arnav, I have come to know that you can calculate the multiplication table of any 3-digit number. So please tell me the multiplication table of 257.
257 514 771 1028 128 1542 179 2056 2313 257.
Okay, really amazing. 679.
679 1358 2037 2716 3395 4074 4753 5432 6111 679.
Miraculous. 873.
873 174 626 194 924 3655 238 6111 698 478 57873.
Arnav, I'm really amazed. How do you do this?
It's all about the magic of math. Vanshika, I also came to know that you are also good in decimal addition. So I have 3 questions for you. First question, 4.6 plus 2.9 plus 7.6 plus 2.3 plus 4.6 plus 5.6.
27.6.
Yes, your answer is correct. I have one more question. 7.9 plus 2.5 plus 4.6 plus 9.9 plus 2.3 plus 4.5.
31.3.
Yes, your answer is correct. I have last question but not the least one. 9.6 plus 2.6 plus 7.9 plus 2.3 plus 5.9 plus 6.3.
34.6.
Yes, your all answers were correct. I was thinking that how could you do this?
It's all about training our mind, and mathematics says, think, think, think.
Yes.
BODMAS is a useful acronym that tells us the order in which we have to solve the mathematical problem. Here we have our BODMAS ninjas of Kullachi Hansraj Model School. So Arnav, 25 plus 36 plus 69 minus 65 plus 28.
93.
Karika, 25 into 6 plus 36.
Ma'am, 186.
Vanchika, 85 divided by 5 plus 36 plus 32 minus 48 plus 37.
74.
Aryan, 45 into 5 plus 36 minus 21.
Ma'am, 240.
Dhairya, 78 into 6 plus 38 plus 49 minus 500.
Ma'am, 55.
Arnav, 47 into 6.
282.
Kanika, 128 into 9.
1152.
Vanshika, 1.2 plus 1.3 plus 3.6 plus 4.5 plus 9.8 plus 7.3.
27.7.
I am amazed to see your performance. Very good, everyone. Thank you.
I am so inspired by the famous mathematician Srinivas Ramanujan. In our school, we have acquired the skills of fast calculation. So, Ayush, let's play a game. Are you ready?
Yes, Sarish. Why not?
So, 175 into 6.
1050.
875 into 9.
7875.
476 into 7.
3332.
952 into 4.
3808.
Absolutely correct.
3423 divided by 7.
The answer is 489.
7744 divided by 8.
So the answer is 968.
1845 divided by 5.
The answer is 369.
3948 divided by 4.
The answer is 987.
Yes, that's why we love mathematics.
Do you know addition is one of the important bases of our life?
Yes, indeed.
Madhuresh, I have heard that you are an addition enthusiast. Okay, so here is your first question. 58 plus 69 plus 14 plus 26 plus 37 plus 48.
The answer is 252.
Yes, you are correct. Now second, 51 plus 27 plus 63 plus 123 plus 620.
The answer is 884.
Great. Now last, 11 plus 28 plus 37 plus 46 plus 62 plus 85.
The answer is 269.
Great. It was amazing.
Rubik's Cube is a widely popular mechanical puzzle that has attracted attention around the world because of its unique characteristics. Solving a Rubik's Cube is often thought to be one of the hardest challenges to overcome in life. So here we have Shashwat and Archit. Now you must be wondering that who is scrambling the cube from us? Here we have Archit's mother and Shashwat's sister. They will scramble the cube for us. We are very grateful for them for conducting this activity. So Archit and Shashwat, are you ready? So your time starts now.
Done.
We are amazed to see this. Archit, you did this in just few seconds. Very nice.
It was an impressive performance. Not only these children, but every child in Karachi Youngstown Model School has the skill of a number cruncher. Not only does mathematics underline every process and pattern that occurs in the world around us, but also a good understanding of it will help enormously in our everyday life. So here we have Suhani Mishra. Let us see how a child perceives mathematics in Suhani's window.
Oof, this alarms annoys me a lot. Huh? What's happening to me? Why am seeing numbers everywhere? It's very strange. Huh? Oh, I got it now. It's because this alarm is telling me times with numbers, and that's maths. Like rectangle, triangle, circle. That's maths. I got it now. Hey child, I'm going outside. Switch off the gas after 3 whistle. Okay? Huh, okay. You got it? I'm going to Sharma auntie's house. Switch off the gas. I know. 3 whistles. You know nothing. No 3 whistle. 6 whistles this time. I'm making sarson ka saag. What do you think? Only you do maths. We also have to do lots of calculation while cooking. Now switch off the gas after 6 whistles. And if I'm a good cook, I'm a good mathematician. Okay? You got it? Now my mind is whistling. Maths in the window. उसमें तो दिमाग की सीटी बज गई.
Hi. Hello. But why are you so sad? I am sad because everyone say that I am a big zero. Oh, you are a zero? What? No. Are you making fun of me? No, I am not making fun of you. I am saying this because zero is a great number. But how that's possible? So listen, 1 crore has 7 zeros. What if all the zeros disappeared? Only one will left. And 1 is nothing without 0. So 0 is a hero.
Games 2. I love playing with my younger sister, but I want her to learn something new. That's why I made this maths game, and it's part of my everyday life. So I love maths.
Maths, 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 maths. Maths, 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 maths. Everywhere maths, everywhere maths. Here maths, there maths, everywhere maths, 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 maths. Math, 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 math. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
I have a magic stick from which I solve maths with ease.
Oh, my mom is also a good cook, which means she's a great mathematician.
An intuitive mathematical genius, Ramanujan and his discoveries have influenced several areas of mathematics, but he is lauded for his contributions to number theory and infinite series. Taking inspiration from his thoughts and ideas, we have started exploring mathematics.
Vanchika, do you know about Ramanujan?
Yes, we celebrate the birth anniversary of Ramanujan as National Mathematics Day.
But do you know about the legacy of Ramanujan?
Not much.
So here we have episode 2 of the play, in which we will know more about the man who knew infinity.
Srinivas Ramanujan, a younger, was born on 22nd December 1887 in Old India in small district town of southern India. His father's name was Kopuswamy and mother's name was Komalatamal.
Happy to know about the birth of the child, eager to know about his future, Ramanujan's father went to the priest. As destined by Almighty, father was told by the priest that your son has a short lifespan and will not live long. Sad father with no hopes went home after this.
Little Ramanuj grew up in the temple town of Kumbakonam, located near the banks of river Kaveri. During his childhood, he went to Kangyan Primary School. In 1898, the town high school Kumbakonam was the school the magical world of numbers, trigonometry and geometry opened for the ever curious Ramanujan.
बच्चों, यदि 3 केलों को 3 बच्चों में बांटा जाए तो हर बच्चे को 1 केला मिलेगा और यदि 1000 बच्चों में 1000 केले बांटे जाएं तब भी हर बच्चे को एक ही केला मिलेगा और इसी प्रकार से किसी भी संख्या को उसी संख्या से भाग करने पर उत्तर एक ही आएगा, समझे? बोलो।
गुरुजी, अगर शून्य से शून्य को भाग दें तो क्या तब भी परिणाम एक आएगा?
रामानुजन, तुमने यह प्रश्न कहाँ से सीखा?
गुरुजी, उत्तर सीखते हैं, सवाल तो सोचते हैं।
रामानुजन, क्या तुमने इस कक्षा का गणित पूरा कर लिया है?
जी गुरुजी, मैंने अपने कक्षाओं का गणित भी कर लिया है।
तुम सवालों को हल करने के लिए किसकी सहायता लेते हो?
गुरुजी, मैं सवालों को स्वयं हल करता हूँ।
कहाँ से पढ़ते हो?
गुरुजी, बड़ी कक्षाओं के छात्रों के साथ मेरी मित्रता है। वह मुझे पुस्तक दे देते हैं और मैं उनके सवाल भी हल कर लेता हूँ।
शाबाश, बैठो बैठो।
जी गुरु।
अन्य छात्रों से अलग जब उनके सहपाठी खाली समय में खेल कूद करते थे, वहीं रामानुजन गणित में इतना मग्न हो जाते कि वही उनका खेल बन जाता।
In 1903, the book that changed Ramanujan's life is Carr's Synopsis Elementary Results in Pure Mathematics. Borrowed from the local college library, he engrossed himself in its methods of analysis and demonstrations. In 1904, at the age of 16, based on its outstanding performance in school, Ramanujan won a scholarship to the Government Arts College in Kumbakonam.
It was over blessing of the goddess Lakshmi Namagiri, who blessed me with equations and numbers. In sleep, many equations and numbers cloud my mind, and in morning I used to write them in my notebooks.
He was totally into mathematics, due to which he neglected all other subjects and the college did not renew his scholarship. So in 1906, he moved to Pachaipa College in Madras, but there too he concentrated exclusively on mathematics and did not pass the necessary examination to enter the University of Madras.
From the age of 14, Ramanujan wrote down his mathematical findings in 3 notebooks, which has become famous now as Ramanujan's frayed notebooks. These notebooks contain a treasure of over 4,000 theorems, corollaries, and other results. In 1909, Ramanujan's parents arranged his marriage to a barely 9 years old girl, Janki. Soon, household responsibilities compelled him to leave Kumbakonam and look for a steady job in Madras. For some time, he tutored students in arithmetic and somehow lived a frugal livelihood. Finally, he got a clerical job, largely due to Chairman Sir Francis Spring of the Madras Port Trust getting thoroughly convinced of Ramanujan's mathematical interest.
Of community in India helped Ramanujan. One was Ram Swami Iyer, a government servant who was the founder of Indian Mathematical Society, encouraged Ramanujan to write his journal and to publish, and then Ramanujan's earliest papers on number theory and elliptical functions came in Journal of Indian Mathematical Society.
I beg to introduce myself as a clerk in the Madras Port Trust. I am now about 25 years of age and striking out a new path for myself. I have made a special investigations of divergence series. The results are termed by local mathematicians as startling, but they are not able to understand me. If you are convinced that there is anything of value, I would like to have my theorems published. To Professor G.H. Hardy, Trinity College, Cambridge.
Hardy was amazed to see the work of Ramanujan and thought he must be a mathematician of the very highest orders. Ramanujan's letter to Hardy, dated 16 January 1913, was one of the most famous letters in the history of mathematics. In the late 1920s, after Ramanujan's death, the letters written to Hardy produced numerous papers by several mathematicians.
The most remarkable aspect of Ramanujan's encounter with the West was that for the first time and in his own right, he could pursue the professional career of a creative mathematician. The First World War years saw Cambridge University almost deprived of students, but the collaboration of Ramanujan and Hardy stands highlighted for its outstanding contribution to the number theory.
Seven Indian research students wrote over 30 papers with Hardy. One of them was Ramanujan also. Ultimately, he was delighted to be finally honored with the University of Cambridge degree. These papers shaped the course of 20th century mathematics in the most unimaginable way.
Cool, damp English climate, wartime deprivation, and a strict adherence to vegetarian diet all conspired to make Ramanujan seriously ill. He was admitted to various hospitals after suffering from tuberculosis.
Ramanujan, I just took a taxi cab number 1729. Seems like a dull number to me. What do you think?
One seven two nine. It is the smallest number expressible as sum of two cubes in two different ways. Guess which?
Who? I?
See, 1 cube plus 12 cube or 9 cube plus 10 cube will be equal to 1729.
Oh, I see.
Yes. I'm going back now, home with the same disease inside me.
You know, you have been elected as FRS. You are a success. They want you here. You must fight your TB. You must.
Back in India in 1919, Ramanujan exhausted all his injuries in formulating a new set of theta functions, today known as mock modular forms. It took 80 years to the mathematicians to unravel what Ramanujan meant with these equations.
A little over a year after returning to India, Anne Elling lapsed into coma and passed away soon on 26th April 1920 in Chetiar Bungalow,
Geometra Madras.
Ramanujan recorded the discoveries he made in the last year of his life on a collection of loosely ordered sheets of paper, which were dispatched to Hardy after Ramanujan's death. But several years later, this collection was misplaced and so it came to be known as the Lost Notebook. This collection was rediscovered in 1976 when mathematician George Andrews looked upon it. In a box of library of Trinity College, Cambridge, he found the last letter Ramanujan wrote to G.H. Hardy in the last year of his life, 1920, and it contains the discovery of
Honors given to our great mathematician Srinivasa Ramanujan. Let us know about the various awards received by Srinivas Ramanujan. Various contributions made by our great mathematician Ramanujan. One of the major contribution is about the black hole discovery. He has also discovered the large spectral gap graphs, which are nowadays used in networking partitions for communities and analysis. Various Ramanujan type graphs are being famously used in applications such as Facebook.
Let's know what we learned from a great mathematician, Ramanujan.
Focus. Stay true to your dreams in the face of adversity.
Know your strength.
Put yourself out there.
Wow! Now I got to know about Ramanujan and his discoveries and achievements.
Orange, this is not the only skill, but our friends can also depict mathematics with their postures.
What? With postures?
Yes, so dancing lifts everyone's spirit up. I am so excited to watch a unique dance performance based on tatting, yoga, and Bharatanatyam by the students of classes 7 and 8 on mathematics.
Wow, performing arts maths is there in performing arts too. I'm overwhelmed. Sorish, now let us explore mathematics around us. It is in construction, in video games, even in fashion designing.
How do you know?
So let us meet the students of class 7 and 8 to learn more about mathematics.
Smriti, you have a client meeting at this time?
No, I'm having a virtual meeting with my school friends after a long time. I'm so excited.
Oh, you mean to say Anshika, Shashank, and that boy you used to call Aryabat?
Yes, there he is, Viraj. Hi, how are you, Aryabatji? What are you up to nowadays?
Hello Samriddhi. Yes, I am a game developer now.
But you were always so studious. How come you have ventured in gaming?
I used to be fascinated by the games in the manner that how gun is shot to perfectly hit the target or what should be the angle and the speed of the car to cross hurdles and time taken to finish the line is minimum. और मैथ्स के सब चैप्टर्स लाइक वेक्टर थ्योरी, अलजेब्रा, प्रोबेबिलिटी, स्टैटिक्स और कैलकुलस सब अप्लाई करके ही तो गेम क्रिएट होती है जो तुम सब एंजॉय करते हो. बट यस, आई गेट अ लॉट ऑफ मनी बिकॉज ऑफ यू पीपल. एंड थैंक यू धनिन फॉर बाइंग माय ऑल गेम.
विराज, मैंने आपकी गेम खेली थी, मेरे को बहुत बढ़िया लगी थी.
धनिन, तुम्हारा तो मैथ्स में बिल्कुल भी इंटरेस्ट नहीं था. अब तुम क्या कर रहे हो?
And I have joined my father business of construction. I used to think कि पापा का business करने के लिए इतनी deeply मैथ्स पढ़ना ही क्यों है? But now I learn the business requires a lot of calculation, estimation, budgeting, taking measurements, trigonometry, geometry, statistics and cost cutting. और हाँ, मैंने सारा मैथ्स अभी पढ़ लिया है.
Yes, it is not bad to learn. Good luck, my friend.
और स्मृति, तुम फैशनिस्टा बनी हुई हो?
Yes, I'm still into fashion designing only. Yeah, guys, I thought that after school I don't have to study maths. But yes, in fashion designing field, it is not just about clothes or designing. Measures के साथ extra margin कितना होना चाहिए? Avoiding cloth waste and executing every design to perfection requires all geometrical skills. Return on investment, inventory, cost of item. We have to decide the price of the clothing. All depends on mathematics only. Hi Shashank, what are you up to nowadays?
Hello everyone, I have a manufacturing unit and from the very beginning it's maths all along the way. What quantity to be produced, what methods are to be followed and how to increase production. क्या statistics, ratio and probability, algebra सब यूज होता है. हर जगह बस मैथ्स ही मैथ्स है. Hello Nishka, good to see you after a very long time. I miss your pastries and cookies a lot. Are you still baking those pastries and cookies?
Yes, friends, still baking cakes and making shakes. Learn baking from international recipes also. Every recipe needs measuring fraction, cooking time, temperature adjustment, ratio proportion. In cakes, ratio of x is to flour is 1 is to 2. In this scenario, knowledge of maths come handy as it is a universal language all over the globe. Measuring units same as gram to kilogram, liter to milliliter, volumes in cubic units. याद है मैम बोलती थी क्यूबिक यूनिट्स वॉल्यूम. एंड सताक्षी, तुम्हारी स्टैटिक सेंस इंटैक्ट है?
Hello friends! Yes, I am into interior decorating now. Starting में तो मुझे लगा कि decorating में maths का क्या काम? But later on, I realized each cabinet, wardrobe has to be made inch by inch, millimeter by millimeter, with exact precision. Everything has to be ergonomic.
ये ergonomic क्या होता है?
It means each furniture piece is
designed and placed in such a manner so as to improve people's working conditions and help them work more efficiently. Oh, so friends, this is our journey from 5 years olds to 25 years olds, realizing that we can't survive without maths. So all of us are surrounded with maths and can survive only with it. Thank you.
It was fabulous.
Now we have parents who wish to express their gratitude towards Ma'am Principal and school for giving this wonderful opportunity of online learning with some exceptional teaching learning pedagogies. So here we have Vanshika's mother.
Greetings to everyone. I am Savita Bansal, mother parent of Vanshika Gupta of grade 7. I am grateful to Madam Principal for enabling students to learn and perform on this digital platform. I'd also like to appreciate the efforts of all maths teachers who worked day and night with students and they made this event a success. Thank you. Thank you so much.
Now here we have Saurish's mother.
Everyone, I'm Pooja Chopra, a parent mother of Sorish Chopra. Everyone here on this platform, I really love how they speak, how they express, how they explore. I really express gratitude towards Principal Ma'am. We, as parents, are very grateful to you, genuinely guiding our children in their endeavors. Thank you for inspiring, mentoring, and motivating them to explore their talent and also in making them believe that their sky is the limit. Thank you.
Thank you very much, ma'am.
We would like to thank Ma'am Principal, who always motivates us. Special thanks to all the supervisory heads and hearty gratitude to our mathematics teachers. Special thanks to our LMS, Ms. Aditi Bansal. Thanks to all those who are watching the live stream. We are also grateful to the computer department and dance department for helping. Thank you all for joining and supporting us. All the clippings and photographs used in this event are for educational purposes only.
Congratulations to you all, children. Thank you very much. It is always a pleasure to watch you all showing your talent. You are awesome, you are unique, you are appreciable always. Dear students, always be ready to do good for people around you. That is what we learn from the subject mathematics. Thank you to, I would say a big thank you to Principal Ma'am for always giving us chance to show beyond textbooks. Today we have seen KHMS Ramanujans, math number crunchers, mathletes, and professionals using mathematics. Thank you to all the teachers who have done a great job. Without your effort, everything seems meaningless. Thank you to the parents who have helped in accomplishing this journey. Thank you to all the supervisory heads, Roman ma'am, and the dance, music, and language teachers who have added their flavor to accomplish this goal. Thank you so much. Have a nice day. Bye bye. Take care.